Hello friends, myself Vikas Tiwari. Once again I welcome you to my YouTube channel MAP World of Physics, and you can also download us from Play Store by the name Mass Academy Advanced Physics. Okay, so once again just I want to continue with the previous lecture. In the first two lectures just I am telling you what are the basics of circuit analysis. When I am talking of basics of circuit analysis, I am saying that I have gone with 8 tools. Okay, so what are those 8 tools? First one is KVL, that I have already discussed in first lecture. Second one is that is called KCL, that I also discussed in my second lecture. In this third lecture and in upcoming lectures I am going to discuss with nodal analysis. Okay, then I will go with mesh analysis. Okay, then concepts of voltage division theorem, voltage division theorem, then current division theorem, concepts of open circuit and short circuit, concepts of open circuit and short circuit, and finally source transformation. So these are the basic 8 tools, okay, for analysis of circuit parameters or circuit analysis, source transformation. Okay, in this context, in my third lecture I am going to discuss with nodal analysis. Okay, so what is nodal analysis? That I have already told you that it is nothing but it is the extension of KCL only. Okay, so when we are going with number of nodes or the number of nodes has been increased, then there is more significance of nodal analysis rather than KCL. So just I am saying it is just the extension of KCL. Okay, fine. So what I am saying, just I am going to discuss with nodal analysis. Okay, one thing, this is very powerful tool. Okay, why I am saying that this is very powerful tool? You can solve 90% of your complex question using nodal analysis. That why it is very powerful tool in the circuit analysis. So let us start with the nodal analysis. What is basically a nodal analysis? When I am talking of nodal analysis, I have made already clear what is the difference between node and junction. And when I am talking of nodal analysis, I am talking about junction only. Okay, so I am dealing with the junctions. Junction means where current divides. Okay, so how we can analyze this particular thing? For that I am taking a very simple circuit. Okay, in this simple circuit, if we'll go for node or junction, we can say this is reference node or ground node. So we are not taking it into our counting because this is the return path for the currents. Okay, so I will say that there is one node or junction over here. Okay, so this is one node over here. Okay, so what we are doing using nodal analysis? First we will find the potential of a unknown point, unknown node, potential of unknown node. Okay, so when we are talking, we are saying we are finding the potential of unknown node. So we can say there is one node, so we can consider that the potential of this node can be taken as VA. This is unknown voltage. I don't know what is this particular voltage, but to get what is the value of this particular voltage, okay, I will say I will always keep this unknown potential at higher potential. In circuit analysis, we will say there are only two potential points, higher potential and lower potential. Plus we are taking higher potential and minus we are taking lower potential. So if I will go with higher potential or lower potential, so I will say I will consider at it higher potential. So now what we are saying, there are 3 branches associated with this particular node. Okay, so this is very first branch in which one resistance R1 and a voltage source V1 has been taken. Okay, and this is second branch in which R2 resistance is there, and this is third branch in which a voltage source and a resistance over here. Okay, so we have to, what is the ultimate aim? Ultimate aim is to find the current in these branches. Okay, so how we are going to find the current in these branches? Just by analyzing this potential VA. What is the value of this VA? We can analyze, okay, current in these particular branches. How we can analyze? Just we can see. So I have already told you that potential of unknown volt is always considered at higher potential. Higher potential means whatever be the value of V1, this is ground node, the voltage of ground is considered as 0 volt. Okay, so whatever be the voltage of V1, I will consider VA as always at higher potential. Okay, so I will say that when VA is higher potential, in that constant in context, V1 is at lower potential and this is also lower potential. So a current flows in this particular branch and say this is the current I1, current flows over here. Okay, so again, if I will say what are the voltages over here, only two voltages, ground voltage and this particular voltage, this is already 0 volt, so I will say a current flows I2 over here. Okay, and here in this voltage, whatever be the value of this voltage V2, I will consider VA as a higher potential. So I will keep it at higher potential. So VA, I will say that the current flows, because the flow of current is from higher potential to lower potential, that's why I have considered it as at higher potential. So the current flows in this branch like this, in this particular direction. So this is the convention that we have already taken. Okay, so now I will talk a simple rule regarding that. A simple rule regarding that, if I will say what is the value of point means unknown voltage, unknown point means a point, in our this case this point VA. Okay, so the unknown point. Okay, and when we are talking of battery terminal, so if I'll say that unknown point is taken as positive, because I am taking it as positive, and if it faces the terminal of battery as positive, okay, positive terminal, then resultant I will take between two voltages as negative. Okay, so when the point higher potential plus faces plus terminal of the battery, the resultant between two voltages is taken as negative. And when unknown point, which is I am taking at always at higher potential, if it faces with negative terminal of battery, as in this particular case, so this is facing this negative voltage. Okay, so I will take resultant as positive between two voltages. Okay, so this is the basic rule that we are going to follow throughout in by applying nodal analysis to particular point. Okay, and one more thing, that is the number of node decide the number of equations. Okay, if they are one node, so there is equation formed will be 1. If there are two nodes, okay, so the number of equation formed will be 2. And if they are n unknown nodes, voltages, so there are n equations in that particular context. Okay, so now I will say that if I am going to apply the node at point A, suppose I will take this, name this point as A, so I will say applying KCL. First I will applying KCL at point A. Okay, later on we will directly apply node directly, but now I am telling you one more step. So when we will apply the KCL at this point A, so by the convention I have already told you that outgoing currents I am taking positive and incoming currents I am taking negative. You can take vice versa also, but I am taking as, okay, outgoing current I1 plus I2 plus I3. All the three currents are outgoing because I have already taken this point at higher potential. So I1 plus I2 plus I3 is equal to 0. What is the power of node? That it will convert the current into voltage. And when, how the current will convert into voltage? We will say V is equal to IR, then I is equal to what? V upon R. So whenever I am going to whenever voltage has been divided by resistor, then its dimension is equivalent to current. So what I am going to do here, just I am converting this current I1 into voltage. How I am? By using this particular rule set. So what is the value? This is the plus voltage. Whenever the plus voltage facing the plus, the voltage between these 2 points is always taken as, resultant is taken as negative, VA minus V1. Whenever say plus face plus face plus, resultant is minus. So VA minus V1 upon R1, VA minus V1 upon R1. Okay, so this is I1, this is I1, plus there is no other battery sources in this branch. You can also write this voltage also 0, ठीक है, but I am saying there is no significance of 0, so I am writing it like this. Okay, so next is, in this particular branch we can say VA upon R2. Okay, so this is I2, this is the value of I2, and what is the value of I3? Plus terminal faces negative, so it will be equal to VA plus V2 upon R3. I have already told you that whenever the voltage, whenever the sign of unknown point faces negative terminal of battery, the voltage is resultant voltage is taken like this. Resultant between two voltages is positive, and it is equal to sum of all the currents is equal to 0, provided that V1, V2, R1, R2, R3 all are known quantities. So there is only one unknown. Okay, so there is only one unknown in this particular value. So you can easily solve the value of, like in the mathematics, x plus 3 is equal to 0. So this is only one variable over here, or we can easily find the value of x like this. So we can also find the value of VA. Okay, so by putting the mathematics like this, VA upon R1 plus VA upon R2 plus VA upon R3 is equal to V1 upon R1 plus V2 upon R3, and solving for VA we will get the value of VA. Okay, so now here what I have said, if the value of VA, after solving this particular equation, if the value of VA is positive, okay, if it is positive value, then whatever the convention we are taking, we will say this is correct. Okay, but if we will find the value of VA is negative, what does this mean? The value of VA negative indicates that the current is flowing in opposite direction. It means V1 is greater than VA. If VA is positive, it means VA is greater than V1. Okay, and if VA is negative, it indicates that VA is less than V1. Okay, so in that particular case we can reverse the direction. Whatever we are assumed over here, we are assuming here current like this, actual the current is flowing against this like that. So this is the basic application, of KCL at this particular node, because there is only one node, so we required only one equation and we can solve the value of unknown voltage VA. Once we will find out what is the value of VA, we can easily find the value of I1. What is the value of I1? I1 is nothing but it is VA minus V1 upon R1. Now VA is known, V1 is known, R1 is also known. I2 is equal to what? VA upon R2. VA is already known, we can find out the value of I2. And what is I3? I3 is equal to VA plus V2 upon R3. Now VA is known, V2 is already known, I3 is already known. So we can find out the current in each branch. Even in complex circuits, we can find current in each branch by using the nodal analysis. In this context, again I am taking one more example, just I will take another case regarding that. But we can follow the same rule set that I have already told you. If unknown point faces battery terminal, positive battery terminal, resultant is minus. If unknown point faces negative terminal of battery source, the resultant between them is positive. Okay, so what I am telling you, so this is the particular phenomena that I have already told you. So now I am taking another example. Just I have extended the circuit, okay, to this one. Okay, this is V1, V2, say this is R1, R2, R3, R4 and R5. Okay, so what we will say now, the number of nodes are here, so you know that these are same equipotential points. So this is only one node and this is ground node. I am not going to count it in my node calculation. Okay, so what is the node? Node means junction, so current divides over here. So this is point A. We can consider the voltage at VA, and at this particular point we will consider the voltage VB, say this point is B. Okay, so now how I will apply? The first thing is that now there are number of nodes is 2, so I require 2 equations to solve the values of V and VB. Okay, so this is the very first fact. And the another thing is that whenever I am going to solve VA, okay, so whenever I will going to solve VA, okay, the another node VB is considered VA. Whenever the VA is positive, when I am going to solve VA, in that particular case VB is taken at lower potential minus, because VB is not on ground point. Okay, here the 3 branches are terminating on the ground. Here also this branch is terminating on the ground, this branch is terminating on the ground, but this point is not terminating on the ground. So in that case, any one of the voltage is taken as positive or negative. So but what is the method? Method is that whenever I am solving node A, VA is taken as positive and VB will taken as negative, while when we will solve VB, VA is taken as negative and VB is taken as particular positive voltage over here. Okay, so just I am going to solve whenever I am going at apply node at A. Now I will apply node directly. Apply node at A. When I will apply node at A, I will consider VA as positive and VB as negative. This is V point. I will consider it as, okay, so the direction of current will flow like this, like this, like this. Higher potential to lower potential, higher potential to lower potential, higher potential to lower potential. Okay, so if I will apply the KCL, I will apply the current in this particular branch by using this rule set, then the point positive is facing positive terminal of the battery. So resultant between them VA minus V1, and it will convert into current by dividing the resistance R1. So VA minus V1 upon R1, okay, plus in this particular point VA upon R2, because there is no other voltage source in this particular branch, and here also there is no voltage source, but there is a potential difference. Means there is a potential difference between VA and VB, which can be written as VA minus VB upon R3, and sum of all the currents is equal to 0. So this is very first equation. Put it equation number 1. Okay, and now when I am going to apply node at B, okay, so when I will apply node at B, okay, so I will say VB is taken as positive, and in that particular case A is taken at negative. So in that particular case we just forget what is the direction of this current, and we will remember the current flow like this in these 3 particular branches, because VB associated with these 3 particular branches. In that particular case, now I will say this VB as higher potential, VA is lower potential. Then for this branch we can write VB minus VA upon R3. Okay, then for this particular branch VB upon R4 plus this plus faces negative terminal of the battery. When plus faces negative terminal of the battery, the resultant between two voltage, the sign between two voltage will be taken as positive. So I will say VB plus V2 upon R5 and it is equal to 0. So this is 2. This is nothing. These two are simultaneous equation that we are solving in our lower classes like 10th classes, 9th class, like that. So these are the two simultaneous equations because I have already provided that V1, V2, R1, R2, R3, R4 and R5 all are known quantities. V1, V2, R1, R2, R3, R4, R5 all are known quantities over here. So just I will say what I will say, there are two unknowns. Okay, so two unknowns and two equations. So for solving two unknowns we require two equations, like that the two simultaneous equation that we are going to solve previously, 3x plus 5y is equal to 10. So these are the two simultaneous equation and we can solve these simultaneous equation easily. So this is the second case that I have discussed. Okay, if I will modify this particular question, okay, how I am going to modify this particular question, just I am putting a battery over here. So these are the 2 points and just I will modify a little bit. How I will modify a little bit, I will introduce one more battery over here. So the value of this particular battery is taken as V3. Okay, so this particular battery V3 is, if we are going to take this particular battery V3, so what is the change in this particular these two equations? Okay, so that I am going to tell you. Okay, so when I am applying at node A, just see the change, differentiate the change what I am taking. When I will solve VA, VA is taken at positive and VB is taken as negative. So current will flow like this, current will flow like this. For this branch I will write the same thing that I have written here, VA minus V1 upon R1. Why I am saying plus is facing the plus terminal of the battery. Okay, for this branch also there is no change. Okay, so VA upon R2, VA upon R2. So this is also change, but there is the change in this particular term. Why there is a change? Because I have already introduced a battery over here. So now I will apply the point and battery rule first. So I will say the positive terminal will face the positive of a point will face the positive terminal of battery. This is positive, this is negative, so it will face. So when plus resultant between them is minus. So I will say VA, I can write it here. So I will say for this term VA minus V1 upon R1, okay, plus VA upon R2, VA upon R2, and for this one plus is facing plus, so I will say VA minus V3, VA minus V3 divided by VA minus V3, okay, not divided by, still one point is, so VA minus V3 I will write like this, okay, rule of plus and plus VA minus V3, and B point is at negative terminal, lower potential VB upon R3 and it is equal to 0. So see the change between these two things. Okay, so equation 1 and this one, there is a change when I have introduced a battery over here. So once I introduced a battery over here, this is the particular change between these two equations. For the change in this particular set, I will consider B point at positive and A point at negative. In that particular case, I am writing here this particular equation. For this one, when VB is facing negative terminal, plus point terminal, so I will write VB plus V3, okay, but VA terminal already at lower potential upon R3, okay. So see the change in this particular term. It is VB minus VA upon R3. Now it will become VB plus V3 minus VA upon R3, plus for this one there is no change, VB upon R4, okay, and for this particular term plus faces minus 1, so it is VB plus V2 as it is over here, divided by R5 and it is equal to 0. So this is the second equation, this is the first equation and this is the second equation when I am facing when I have made a change in this particular circuit by introducing a battery V3 over here. Okay, so these are the three particular cases that I have discussed over here. Okay, so this is what we called the application of nodal analysis. So this is very powerful tool just in solving the complex electric circuits when you have more than 1, 2, 3, 4 nodes like that. So this is very powerful in solving in that particular context. Okay, so this is all about the nodal analysis. What is nodal analysis? What are the rule set we are using? How we have applied on the circuits, and this is the complete analysis over here, and I hope you can understand the depth of it. Okay, so we will in our next lecture we'll go with one more thing that is called mesh analysis. So in our upcoming lecture I will continue with the mesh analysis. Thank you very much.